All right, this video is for anybody in the 8th period class that is gone for volleyball, or I guess anybody gone in general. Section 1.6 is what we're doing today. Solving systems of equations. So what's going to happen when you're solving systems of equations is you're going to be given two equations like this. They may not necessarily be solved for, like these two, the y's are solved for. The reason why it says y1, y2 is just to note that they're two different equations. So y equals negative 2x plus 8 and y equals 4x minus 7. And what we're trying to do is those two are linear functions because we're still doing with lines, and one is probably going this way of some nature and one is probably going this way of some nature. And to solve it, we're trying to find this spot right here where they cross. That's all we're trying to find, okay? So there's three different methods of doing that. There is first, I don't know why I keep glitching out. Okay, there are three different methods. The first method is to graph. So method number one, we're gonna kind of alter the instructions on example one, but first method is to graph. The second method is to use the substitution method. And the third method is to use the elimination method, okay? I'm hoping that maybe after we get into this that you'll start to kind of recall and remember what some of this stuff is. Okay, so example one, solve by using a table. I don't know why it keeps doing that. I don't know. I'm not plugged in all the way somewhere. All right, example one, solve by using a table. I don't know that I really want to solve by using a table. I'm going to alter the instructions here. Can I do that? Because we're big kids and we don't like plugging things in. We don't like solving for a table. So let's do this. Let's go ahead and solve this equation for y. And let's solve the second equation for y also. Let's get the y's by itself, and then we're going to graph, and then we're going to move on, okay? So to get this y by itself, we subtract the 3x first, right? So we have 2y equals, and then how do you put that in order? Negative 3x minus 1. Yep, exactly. All right, and then we divide by 2. Divide by 2, divide by 2, divide by 2. So y equals, and we're going to leave it as negative 3 over 2, x minus a half. And that's what he's going to look like. Okay, next. This is going to be kind of ugly. Add the 4x over. X and 5y is equal to 4x minus 28. And then divide by 5. This is really not nice. Ugh. Y equals 4 over 5x, and then what's 28 divided by 5? 5 and 3/8, 5.6, minus 5.6. We'll go with that. So those are the two things, and we are tasked with graphing them. We were going to use the table, but we're going to graph them, and we are going to find about the place where they cross each other. Just about where they cross. Something's not hooked in here right. I don't know. All right. So the first one to graph him, we started the negative 1/2. So I'll put him a dot about right there. And then from there we go down 3 and over 2. Right? Down 1, 2, 3, and over 2, something like this. That's what my line is going to look like. Okay? Something of that nature. And then the next one, we go to negative 5.6. I'm going to graph him in green. Negative 5.6. 1, 2, 3, 4, 5.6 is about there. I'm going to put a dot. And then from there, I go up 4 and over 5. So 1, 2, 3, 4 over 1, 2, 3, 4, 5-ish. Something like that. Oh boy, my line is really curvy. All right, something like that. And what we're trying to find is this solution point where they cross each other, and do you have any guesses? Whereabouts do you think that is? My line's kind of curvy. You think it's 1.5? I think it's past the 2 mark. Here's the 2 mark. It might be right on 2. 2 comma, what's this one right here? Negative 4? Sure, 2 negative 4. We'll go with that. Okay. Maybe that's the right answer. Maybe it's not quite 2, -4, but that's what we're looking for. That's what we're trying to do when we graph. Okay, so we can already kind of see like some of the downfalls on graphing, right? I have bad handwriting, but I know Eli's is worse. So if mine, you can't figure out where it crosses, I know you're not gonna be able to find on Eli's, right? If it doesn't cross at a very good point, that's one of the downfalls of graphing, right? Like, we go to all the work of graphing it, and we still don't know where it's at, especially if it lives not at a good point, okay? So that's one of the downfalls of graphing. Let's go again here, and we need to solve this system right here. We got to get the y's by itself. So let's subtract the 2x over. Okay, be careful of that y, because it stays a negative y is equal to negative 2x minus 1, but then divide by a negative, right? Divide by kind of a -1 when you're dividing. Y equals positive 2x plus 1. That's the first one that we have to graph. And then the second one. Okay, let's subtract the 5x over. Am I going too fast? No? Okay. 2y equals negative 5x minus 16. Then let's divide our 2. And we get y equals what? Negative 5 over 2x. We'll leave it as 5 over 2 because that's our slope. Minus 8. Okay? And they give us a nice pretty graph over here to graph them. All right, first one, start where? At 1, and from there we go up 2 and over 1, up 2 over 1, up 2 over 1, or down to left 1, down to left 1, down to left 1, and something like that. Okay, very nice. Second one, start at -8, which is like on the tip of the arrow at the bottom, and from there we go down 5 over 2. I don't have a down 5 anymore because I'm already off the graph. Up 5, left 2. So 1, 2, 3, 4, 5, left 2. Oh man, oh man. That's nice. We like that. Man, oh man. Do we have an answer? Yep. A really nice one. What is the answer? -2, like -3-ish? Now, if you weren't sure, how could you check to see if -2, we're not going to, but how could you check? We could put it into both equations here for x and y, and put it here for x and y, and it should check out, right? We could do that, okay? That's always an option. All right, now, you might end up with something, and you can cross off the words inconsistent, dependent, independent, all that good stuff, because I only want to know whether it has no solutions, one solution, or infinitely many solutions. Okay, so let's talk about what this does. If it has no solutions, the lines are parallel. Okay, so let's put another little note on here. If the lines are parallel, what's another thing that I know about the equations? They have the same slope. Same slope. And I'm also going to put here different b. Okay, same slope, but they are going to have a different b value, like y equals 2/3 x plus 7 and y equals 2/3 x minus 4. Okay, they have the same slope. The slope is 2/3, but they do have a different b. Does that make sense? Okay, now I'm going to skip one solution and we're going to go over here to infinitely many solutions. And infinitely many solutions occurs when you have the same slope and the same b. Okay, same slope, same b. All right, so example of that would be like y equals 3x plus 4 and 2y equals 6x plus 8. Now those don't have the same slope that I can see right now, but do you see what I did? Divide by 2. Yeah, if you solve this guy for y, you would end up dividing by 2, and you would literally get the same equation. So what this is doing right here is it's the same line graphed on top of itself. Ooh. Goodness. So one way you can remember that parallel lines is no solutions is when we're trying to find the solutions is where they're touching, right? And if it's a parallel line, they're never touching. So you have no solutions. Over here, if it's the same line, they're touching like at an infinite number of places, right? They're like always touching each other. So there's infinite solutions there. And then what happens for no solutions? Neither of those two things are happening. It's just something else, like y equals 2x plus 6 and y equals 3/4 x minus 1. Something like that, right? Those two are just going to cross each other. They don't have the same slope. As long as they don't have the same slope, you're only going to have one solution. Make sense? Not too bad. Okay. All right. Graph each system of equations. Describe them as, we're not going to worry about consistent, independent, dependent, whatever. We're just going to say how many solutions. Number of solutions. That's what I'm concerned with. That's what I'm concerned with. Okay? Good? All right, first things first. Solve for y. Are we getting tired of solving for y? That's like 80% of what this chapter is about, is solving for y. So we've got to get the y by itself. All right, let's subtract the 4x. X. So 3y equals negative 4x plus 24. Yeah? And then divide by 3. Divide by 3, divide by 3. Y equals negative 4 over 3, x plus 8. That's the first one. Okay, next. Let's do add 3x. So 5y equals 3x plus 30. And divide by 5. Y equals 3 over 5x plus 6. Those are my two equations. All right, we don't even have to graph. We know what's going to happen. What's going to happen? What? One solution. Those two are just going to cross each other some willy-nilly spot, right? Because they don't have the same slope. All right, let's graph them quick. The pink one, I'm going to start at 8, which is off the graph again, but then down 4. 1, 2, 3, 4, and over 3. And down 4 and over 3, and something of this nature right here. Oh, man. Something like that. Okay. Am I going too fast? All right, start at 6. Up 3 over 5, or down 3 left 5. 2, 4, 5. There he is. Something like that. Okay, and he did in fact cross one spot. Are those two things or perpendicular to each other? They kind of look like maybe they are, but are they? No, because look at the slopes. Negative 4 over 3 and 3 over 5. They're pretty darn close, right? Negative 4 over 3 and 3 over 4 would be perpendicular, but these are not. Okay, it kind of looks like maybe he is, but not quite. Okay, good. Happy with that? One solution. Put that down. And I abbreviate solution as SOLN. If you want to do that also, you sure can. Solution, SOLN. Okay? All right, let's just solve this one. We won't graph because we already know how to graph. Let's add the 2x over. Plus 2x. 5y equals 2x plus 10. Divide by 5. Y equals 2 over 5x plus 2. There's my first one. Happy with that? Am I going too fast? Okay. All right, next, minus the 4x, minus the 4x. 10y equals negative 4x minus 20. And somebody stop me and tell me that I did it wrong. Negative 10y, good. Okay. And then let's divide by negative 10. And divide by negative 10. So we have y equals negative 4 divided by negative 10. The negatives are going to cancel off, but 4 over 10 is 2 over 5. X, negative 20 divided by negative 10. Are they parallel though? So they have the same slope, but they both have the same 2's, right? 2 and 2, so I guess we could graph this. Start at 2, go up 2 over 5. Or down 2, left 5. This is what he looks like. He is the same line on top of itself, right? So he's touching an infinitely many solutions. Have you seen that symbol before? Yep. Did you do this in Algebra 1? I mean, I know you did it, but do you remember doing it in Algebra 1? Yeah, kind of? Okay, good? Happy with that? Sure. Okay, let's go to the back side. Example 4, substitution method. I'm going to, let's do something different. Let's do something different. I'm going to give you an example, and I'm going to give you one of your homework problems, so we'll do one of your homework problems for you. Let's say 2, 4, 6, 8, 10. Find the numbers. Solve each system of equations by graphing. 6, 4, 7, 8. Okay, we'll do number 6 because that'll be a part of your homework assignment. Okay, so x minus 3 equals negative 12, and 2x plus y equals 11. X minus 3 equals negative 12. X minus 3 equals negative 12. Let's see if I can remember that. X minus 3 equals negative 12. X minus 3, is it 3y equals negative 12? And, anybody remember the second one? I can't. 2x plus y equals 11. There you go. 2x plus y equals 11. Okay, I'm canceling out the story problem. And we're going to solve this guy using the substitution method. Substitution. S-U-B-S-T-I-T-U-T-I-O-N. Or it's like the heading here, substitution. Substitution method, okay? All right, you've done this before, but you maybe don't remember. All right, in order to do the substitution method, we have to have something to substitute for. So we have to solve one of the equations for x or y. It doesn't have to be y, it could be x, okay? So I have options here. Are you ready? I could solve the top equation for x. I could solve the top equation for y. I could solve the bottom equation for x or the bottom equation for y. Now, 2 of those are easier than the other 2, right? Which 2 are going to be easy? The top one for x or the bottom one for y, right? Because they don't have a number in front of them. Does that make sense? Okay, which one would you like to do? X on the top? Sure. So let's solve the top one for x. Let's do this guy right here. So to get x by itself, we just simply move the 3y. We add the 3y over. So x equals 3y minus 12. Beautiful. Okay, our x is solved for. This has to be the case. All right, now this 3y minus 12, he can go in the second equation for x, right? Okay. So what do I do with that 2 that's out in front of there? What?
Put that in parentheses.
Okay, 2 times 3y minus 12. That's what he looks like. Does that make sense? I just plug that in for where the x is. And then I have plus y equals 11. So I just took that chunk and shoved it in for the x. Are we okay? Does that make sense? That shoved in for the x. Now, do you always plug it into the second equation? You plug it into the one you didn't solve for. So since we solved the first equation, we're going to plug it into the second equation. Make sense? Okay. So there's how that works. Okay, then we just simplify. So what are you going to do next? Distribute the 2. Okay, so 2 times 3y, 6y minus 24, and then plus y equals 11. I'm just going to rewrite what comes after that, and then we just solve, right? And this is stuff that we solve for, like, in the very first section. What are you going to do now? 6y plus y is 7y, okay? And then can we add the 24 over at the same time? Equals? Beautiful. I like it when that happens. And then divide by 7, y equals 5. 7 equals 5. Y equals 5. Okay, good? And now what? We're not done yet. We have to put that back in for y, so we can put it into any equation that we want to, but really, really nice would be to plug it in right here, because we have x solved for, right? So x is equal to 3 times y minus 12, or 3 times 5 minus 12. 3 times 5 is 15 minus 12 is 3. Beautiful. Okay, but we're going to write our answer as 3 comma 5 because it's x and then y, right? X and then y. Now, why do you care about the point 3 comma 5? What does that do? Yes, these two lines, if I were to graph them, that's where those two lines would meet each other. Make sense? Yeah, that's the substitution method. That is not my favorite method. I like elimination much better. Okay? All right. So let's do you think substitution takes forever?
Yeah.
I agree. Yep. I like elimination much better. Okay, now some elimination problems you have to work a little bit harder than others, but we'll get to that. Okay, so when you're eliminating, what we're going to end up doing is we're going to take these two equations and we're going to add them together, the top and bottom. Okay? All right, don't write this down. If I take 5x plus 8x, that gives me 13x. And if I take 3y plus 3y, that gives me 6y. What I want to have happen is I want to make it so that one of these variables cancel out. Which variable would be really nice to make it cancel out? The y's, the 3y and the 3y. But what cancels with 3y? Negative 3y. So let's multiply by a negative on one of them. The top one or the bottom one? Bottom one. Okay, so let's multiply the bottom equation by a negative 1. We're going to distribute a negative 1 through all that. All right, so I'm going to recopy the top. This is a copy of the top. 5x plus 3y equals negative 19. And then I'm going to take negative 1 and I'm going to multiply everything by a negative 1, which really does just what Eli said. It's going to make everything a different symbol. So 8x will become negative 8x minus 3y equals positive 25. Okay? All right. It's really key to have decently readable handwriting, right? Otherwise, you're going to get lost. If you have really crappy handwriting, you're going to get lost in one of these steps because look at this last problem. Look at how much work we wrote out. It's not hard, but if you have crappy handwriting and you do one thing wrong, your whole thing is going to be wrong, right? If you forget to multiply by a number, your whole thing is going to be wrong. All right, here we go. So let's add what's 5x minus 8x, these two together. Negative 3x. 3y minus 3y cancels out. If it doesn't cancel out, we did something wrong, right? Negative 19 and 25 makes positive 6. And now all we have is 3x equals 6. And then we divide by negative 3. What's 6 divided by negative 3? Negative 2. Okay? All right, now we're not done yet. We got to solve for y. Do you want to plug him into the top or the bottom? Actually, we could plug him into any place we want to. We could plug him in here. 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 Wherever we want to plug him in. Doesn't matter. Where would you like to plug him in? The top one? Okay. 5x plus 3y equals negative 19. We're plugging him in for x. Keep that in mind. So x is going to be negative 2. We're going to plug him in that spot. Okay? We're doing okay so far? Now what? Multiply those together. That gives me negative 10. Okay? Now, add the 10 over. So plus 10 plus 10. 3y is going to be equal to negative 9. And then divide by 3. Divide by 3. Y is negative 3. And the answer is negative 2, negative 3. Happy with that? Okay, these next two I'm going to go through real quick because this is what it's going to look like when you get weird things happen, like no solutions and infinitely many solutions. Okay, this is what it's going to look like. All right, so part A, would you like to use the substitution method where you're solving for one of them, or would you like to eliminate? You want to eliminate. Which variable would you like to eliminate? The y's. Okay, so this one is 3 and this one is 9, and I have to get them to be the same number. So what are you going to change them to? I can just change the top one to be a 9 also, right? But we want it to be a negative 9, so Ellie says multiply him by a negative 3 because negative 3 times 3 will make that top one negative 9. Okay? What? What did you say? Okay, just wait. We'll get to there. We'll get to there, kid. Okay, negative 3 times 5x is negative 15x. Oh, man. Something's happening. Negative 3 times 3y is negative 9y. Equals, what's negative 3 times 52? Negative 156, okay? And the second equation I'm just going to leave right there because we didn't change him at all. And now we have to add them together. Okay? All right. Now, this is where weird things happen, right? And it's totally legal. Weird things can happen. 15x minus 15x goes away. 9y minus 9y goes away. So what's left on the right, on the left side? On the left side, what's over here? 0. 0 equals, and 54 minus 156 is negative 102. So this is what we have, folks, and this is our stopping point because we have 0 equals negative 102. And when does 0 equal negative 102? Never. Never, so that means no solutions. There are no solutions. Does that make sense? If we were to graph this, what would these lines look like? You don't have to write this down, but what? They wouldn't cross, so the lines are parallel. You don't have to put that down, but I'm just going to like connect the dots. P-A-R-A-L-L-E-L. I can't spell today. The lines are parallel. If we were to graph them, those lines would be parallel. Make sense? So when you get to that point, you end up with weird things, right? Okay, let's do part B. Okay, part B. Would you like to substitute or eliminate? Eliminate again. Let's do it. Would you like to do x's or y's? Y's? Okay, so I have 3 and I have negative 6. I want them to be the same number. What are you going to change them to? You have to times the top by 2. If I times the top by 2, does one end up positive and one end up negative? Yes. Okay, so I'm going to times by 2, times by 2, times by 2. 2 times 2x is 4x. Oh, man. 2 times 3y is a positive 6y. And 2 times 15 is 30. Okay? All right, so we add those together. Negative 4x plus 4x is gone. Negative 6y plus 6y. Yes, she is.
She needs to leave now.
Perfect, sounds good. Negative 6y plus 6y is gone, so what's left on the left side? 0 equals? 0. When does 0 equal 0? Always. So there is infinitely many solutions, and if we were to graph this, there would be both lines the same. They're both the same equation. There's infinitely many solutions. So algebraically, when you do the substitution and elimination, they end up canceling each other out. Yeah? Okay, I'm going to have you guys do evens both sides on your handout that we have going on here, and then, yeah, we'll do that. Okay? I'm going to stop the video.